And the anchor is going to be that point, right, where my pan gesture went down. So that's it. It's as simple as that. Now I have an attachment between that point and this dropping view. I'm going to be moving that point as the gesture moves, and the dropping view is just going to follow around. After that attachment happens, by the way, I'm not going to allow you to do it again, so I'm going to set the dropping view to nil. Okay? Because in other words, I'm not going to let you grab onto that thing, move it a little, oops, grab onto it again, move it again. Nope, you get one try. Okay, that's just part of the gameplay. I only want you to get one try at dropping that thing. And then I just say Animator, add behavior, and the instant I do this, it's going to start animating that. Okay, animating an anchor, a connection between that point and that view. Okay, so I think that's all I have to do. Yeah, so let's run and see if this works. All right, so we have them dropping down. I grabbed onto it. You see my mouse? You can see how I'm kind of have a hold of it, and it's like a bar. I can even balance it on top of it. You see? It's a little hard to see, right? So maybe we'll draw a line between the attachment point and the little thing. Okay. Woo. Okay. So that's the next thing I'm going to do is I'm going to draw a line between where I'm panning and the item that I'm dropping. So let's do that. And I'm doing that not as much, partially to show you how the attachment is working, but also because I want to show you how to use this action, this little action block that you can use. So how am I going to draw that? Okay, how am I going to draw this, this line? Well, what I'm going to do is I'm going to make the game view of my storyboard here be a UI Bezier path drawing view. Okay, so I'm going to create a new kind of view. Oops. New file, and it's going to be a UIView, subclass of UIView. I'm going to call it Bezier path view. Okay, and this is going to be a totally generic Bezier path drawing view. So its public API is it is going to have one property, public property, which is a UI Bezier path called path. All right, that's its entire public API. And all it's going to do is in its drawRect, it is going to say path stroke. Okay? And the only other thing I'm going to do is self.path. And the only other thing I'm going to do here is in set path, the setter for that thing. I'm going to do under our path equals path, and I'm going to say self set needs display. So anytime someone changes the path, it's going to redraw it. Okay, everyone understand what this class does? I hope, right? This combines everything you know about drawing, right, in one thing. drawRect, Bezier path stroking, set needs display, the whole thing. So that's it. Now I'm going to go back to my storyboard, and I'm going to have this game view, instead of being a UI view, I'm going to change its class to be Bezier path view. Okay, so everyone remember what I told you about. If you have a custom view like this, if it starts out generic, when you drag it out, right, it starts out generic, and you can change its class, just like with the controller. Okay, now to match this up in my controller, I better go up here and say that this is a, where is that thing, my game view, is a Bezier path view, so let's do that, Bezier path view, oops. All right, so it's a Bezier path view, so that I can send it Bezier path messages, okay? All right, so now my game view can display an arbitrary Bezier path. So now all I have to do is calculate the Bezier path that the attachment shows, basically between the anchor point and the dropping view. And then every time that attachment view changes, I have to redraw. I have to reset that path, recalculate it every time. Okay, so that's where this action block is going to come into play. All right, so how are we going to do that? Let's do it right in here. Okay, when we create this attachment right here, we are going to use the little action block of this guy, action, to update that thing. So let's go caret, curly brace, okay? This is how we specify a block. So we're going to pass this block of code off to this attachment And every time it animates, it's going to call this block of code. And what are we going to do in this block of code? Well, we're going to create a Bezier path. We're just using UI Bezier path alloc init. And this Bezier path needs to have a move to, so let's have it move to the anchor point of the attachment. So that's self.attachment.anchor point. And then we're going to path add line to. We need to go to where the dropping view is. That's self.droppingView.center, right? And now we have that path, so I can just say self.gameView.path equals path. Okay? Any questions about this? Yeah.
Why do you need to go and attach it to self.attachment.anchorPoint? Aren't you passing an anchor point into that method already?
Yeah, so the question is, couldn't I just say right here, anchor point? Because I'm passing anchor point right here. And the answer is no, I can't do that because I'm changing the anchor point, right? Every time you move that pan, I'm changing that anchor point. So this block of code gets executed every time that happens, so I can't use this anchor point, which was only passed in here when I first attached it. I have to use self.attachment.anchor point. In other words, the anchor point's current attachment point, right? So that's why I have to keep calling that, yeah.
Since you're setting self.droppingView to nil after you set that block, will that affect what happens in the block?
Yeah, excellent question. So I'm setting this self.droppingView to nil, and I'm using self.droppingView in here. Isn't that going to break it? And the answer is absolutely it is. Okay, I did this intentionally because I wanted to show you that the things that are in here get reevaluated every time. This block gets executed each time the animation happens. So how can I deal with that? Well, I can just, how about create a little local variable here called droppingView equals self.droppingView. And then I will use that right here. Okay, so now I've captured the dropping view here in a local variable, and I'm using it here. So this is referring to this local variable, not to self.droppingView anymore. And the fact that I set this to nil doesn't matter. This one's still going to be pointing to that thing. Okay? So that, I just wanted to kind of show you how blocks capture the local variables that are just outside their scope. Now, we have another problem in here, and in fact, the compiler is warning us about it. You see, capturing self strongly in this block is likely to lead to a retain cycle. That's a memory cycle like we were talking about. And in fact, it's going to, because this action, this block, is inside this attachment, strongly held by it, which is strongly held by us. So we have a strong pointer to this block. And if I put self in here, the block is going to have a strong pointer to us. And that's no good. So we're going to do this trick, underbar weak. UI, what do we call it? What is the name of this thing? Drop it, a view controller. That's our self. Weak self equals self. So now I've created a weak pointer to myself, and now I can use that here, weak self. Okay, also down here, weak self. All right. So if I ever got dropped out of the heap, and no one had a strong pointer to me, these weak self pointers would all go to nil. But that would be fine, because if I'm not around, then this action doesn't mean anything anyway, right? I'm the controller. So it's all perfectly fine to do that. Okay, any questions about what we did there? Because that's an important thing to understand as well. All right, one last thing we have to do is when the gesture ends, the pan gesture ends and we remove the animator, we're going to want to say self.gameView.path equals nil. Okay? Because this action, once this thing is removed from here, this action is not going to execute anymore, so we're not going to get that last action that draws nothing, right? We don't want that line to be left there. Okay? In fact, here, you know, just to make sure you understand this, I'll leave this out and we'll see what happens. Okay, so I'm dropping here, and now see, look, I got my bar. Dance this thing around, woo, drop it where I want. Oh, see, the bar didn't go away, okay, because that action never called. That's because of this line of code. So let's put this back. Now we'll run. Okay, now we drop one, we got it. Drop another one, grab onto the side, another one. Try and swing it around. Okay, if we swing it around and smash it in there, they'll still collide. Okay, these are still collision still happening. And you can see also that our game has a little bit of a problem right now. By the way, this not being able to rotate is why it didn't tip off there. Okay, because it kind of got stuck. It's with being some item behavior is keeping it from tipping off. Okay, this is bad for our game because how are we ever going to line these blocks up here, right? So the next thing we would want to do, and this is what I'm not going to do because of time here, is in the collisions, okay, when collisions happen, collisions have a delegate as well. And in that delegate, what you could do is every time, and the collision delegate tells you when a collision starts and when the collision is ended being processed. Okay, and in that ending handler, the ending message that gets sent by the collision to this collision delegate, in that ending thing, you would then grid the thing up. Probably look at its linear velocity. If it's moving to the right, move it to the right a little more until it lines up. If it's moving to the left, move it to the left a little more until it lines up. See? So it's not too many lines of code, but I want to make sure we cover auto layout today, so we won't do it. But any questions about what we did so far, or what we did here? Okay. Yeah, oops. Okay. All right, so let's get on to the lecture about auto layout. Where's my keynote? There it is. Okay. So what is auto layout? So auto layout is a way of setting the frame of all your views. Okay, and these can be frames of views that you make in code or frames that you drag out into your storyboard. Okay, although I'll warn you for your homework, the frames of the cards that you make in code, you're probably not going to want to use auto layout to lay those out. You're going to want to use like that grid class I gave you or some class you write, okay? Because the rules for laying them out are kind of beyond even what auto layout can do, okay? So that's just a little hint there. But all the other views, every single other view, including the view that contains your cards, you'll want to use auto layout to decide where it gets put on screen. So we're going to decide where to put these frames using rules instead of using numbers. Instead of saying putting it 2020, 180 wide by 200 high, we're going to use rules to decide where it goes. Okay? And these rules are really flexible and powerful, and the rules are mostly about the relationship between one view to another view or between a view to its superview. Okay, now why do we want to specify these frames as rules instead of as numbers? Because sometimes the bounding rectangle that contains all our views is changing, either because device rotated, we're on a tall iPhone versus a short iPhone, we're embedded inside of a navigation controller or not, we're in a tab bar or not, we're on an iPad in some popover controller view or something like that. There's a lot of reasons that our bounds would change size. So we want to build our views so that what's inside of them adjusts automatically, okay? And that's a big part of your assignment, although your views want to, in terms of your cards view, want to adjust automatically anyway because you're adding and removing cards from them, and so they have to adjust anyway, so you kind of probably get that for free. But all the rest of your views, the one that says redeal and score and all that, you're going to want to use auto layout to make those